All right, here we go with individual assignment 8.6, or chapter 8, 8.6.55T. So a physician with a practice is currently serving 280 patients. The physician would like to administer a survey to his patients to measure their satisfaction level. Random sample of 24 patients had an average satisfaction score of 8.3 on a 1 to 10 scale. Sample standard deviation was 1.6. Construct 99% interval. Okay, so again, let's start with what we know. So our big N, or our population, is 280. That's how many total patients they have. And our sample size is 24. So again, that sample size is pretty big. So we're going to have to deal with this as a finite population. Our X bar, or our mean on this, is 8.3. And we have a sample standard deviation of 1.6. And we know our confidence level is 0.99. I always know that my alpha, 1 minus my confidence level. Okay, so I think that's everything we need to know. So we can use the confidence function for this one to figure out our margin of error. And since we're dealing with the sample standard deviation and don't know the population standard deviation, we're going to have to do confidence.t. If we knew the population standard deviation, we use confidence.norm. And it's our alpha, our standard deviation, and our size, which is the sample size of 24. So there's our margin of error, and that would be awesome, except that we have a finite population here. So we're going to have to figure out the finite population correction factor. And to do that, it's the square root of big N minus little n divided by big N minus 1, or the population minus 1. So there's our finite population correction factor. So we will call this our corrected margin of error, which is just the margin of error times the finite population correction factor. And now that we know our margin of error, we can find our lower confidence limit and our upper confidence limit, which is just going to be equal the X bar, or the mean, minus the corrected margin of error. And this is going to equal the mean plus the corrected margin of error. This wants us to do 2 decimal places, so we'll do that. And that should be our confidence interval. So we are 99% confident that the true population mean would be somewhere between a 7.42 and 9.18. All right, what assumption do we need to make for this analysis? So anytime we use the student's t-distribution, we have to assume the population is normally distributed. And that's it. So again, as always, don't be afraid to reach out if I can help in other ways, and have a great day.